Let's continue this. Now we have seen in case of substituent present at ortho position, whether it is electron donating substituent or electron withdrawing substituent, both are going to decrease the basic strength of aniline. So this effect do not have much explanation. It is probably found due to some combined effect of inductive effect as well as steric effect at ortho position. Fine. So in both cases ortho are least basic, and moreover I have told you the substituent present at para position is going to make the effect more pronounced, whether to increase the basic strength or to decrease the basic strength, right? Now let me give you the values of their pKb. So you see here the values of pKb. For the first case it is a 9.21, then it is a 9.34, then it is a 9.38 and 9.58. So you see the pKb value is going to increase, as a result basic strength goes on decreasing. Fine. Then here in this case aniline, it's again we have done it 9.38, here 12.64, here it is 13, and in case of ortho it is 13.22. Right? So we see here as the substituent is electron withdrawing, the pKb value goes on increasing, that is basic strength is going on decreasing in this case. Fine. So aniline is the strongest among them, and as nitro group comes at various positions in the ring, it is going to decrease the basic strength. Fine. So this is one comparison of the substituents. Now further let us have more comparison of the substituents but present on nitrogen, not in the ring, right? So this is very interesting. That is, just now we have discussed the presence of substituent in the ring. They are going to affect the basic strength. Now we will discuss if substituents are present on the nitrogen. For example, we have aniline, and then we have N-methyl aniline, and further we have N-dimethyl aniline. Fine. So if we see their pKb values, then pKb value for aniline 9.38, then for this 9.30, and this is 8.92. So you see pKb value in this direction is decreasing pKb value. So this shows that in this direction the basic strength increases. So it's very simple here. The effect of attraction of lone pair of the nitrogen by the ring due to plus R effect is same in all these cases. That effect is there. But if you observe the substituent present at nitrogen, then there is no alkyl group present. One alkyl group present is going to increase the electron density of nitrogen by plus I effect, and here such substituents are 2, so it is more plus I effect and electron density of nitrogen is more. Moreover, if you observe the stability of cation formed in each case, that is very interesting. In this case the cation formed will be NH3 positive. There is no substituent present on nitrogen to make it stable, but here you will have one alkyl group which is going to stabilize the nitrogen, which is electron deficient by its electron releasing nature, and in the last case you have here two alkyl groups present on nitrogen which are going to stabilize the electron deficiency of nitrogen. So I have already told you many times that you can discuss the comparison of acidic strength, basic strength or any other comparison. One, through reactants, that is availability. For example, in this case I have discussed on the basis of availability of lone pair on nitrogen, due to which the proton will be attracted. Or it is very simple, if you have the same reaction for all, that is what will happen when they accept H plus. So this is the cation form. You can discuss the stability of the cation form. This is the most stable among them and this is least stable among them. So as a result, this is formed much easily. So this is a fast step showing that this is the most basic among them. Fine. And this is least basic among them because here it is least stable. So this step will be very slow. Aniline will have a very less tendency to accept a proton as compared to an methyl aniline and as compared to an dimethyl aniline, right? So this is again a very interesting discussion. This is due to substituent present at nitrogen. Fine. Further, we have one more comparison. We have here aniline, that is C6H5NH2. Then we have here C6H5 twice NH and C6H5 thrice N. That is a primary aromatic amine, secondary aromatic amine and tertiary aromatic amine. Fine. So in this case, if you observe the pKb value for aniline, it is 9.38 and it is 13.2, and here the value is not available. So you see here, as the number of benzene ring goes on increasing, as a result two things are there. Number one, on the basis of steric hindrance is maximum in this case. Here it is a maximum hindrance. Therefore, approach of H positive to nitrogen is very slow because nitrogen is surrounded by three bulkier benzene rings. Fine. Here the steric effect is very less. Moreover, more benzene ring present, so availability of nitrogen, availability of lone pair on nitrogen will be very less because three rings are present, so there will be more attraction of the lone pair towards themselves due to plus R effect. As a result, this is the least basic and aniline is the most basic. So we have seen, if in the previous case we have discussed, if alkyl substituents are present on nitrogen, then it's going to increase the basic strength, but if aromatic substituents are present on nitrogen, they will decrease the basic strength, right? So this comparison can also be asked. We have here, this is diphenyl aniline, this is a triphenyl aniline, right? Okay, so one more comparison. The comparison is between aralkyl amines and aromatic. Very simple, you can be asked a comparison between aralkyl, that is benzyl amine, and aromatic, that is aniline. So it is very simple. You can easily say here nitrogen is directly linked to the ring, so availability of lone pair is very less due to plus R effect. Fine. But here nitrogen is not directly linked to the ring, it is carbon which is linked to the ring. So here availability of lone pair will be more availability of lone pair. So attack of H plus will be fast in this case and attack of H positive will be very slow in this case. And moreover, you can also see from the values here, the pKb value is 4.70 and here it is 9.38. So it is very less, shows that this is a stronger base as compared to aniline. So here we end up this discussion. We have done so many comparison between the basic strength among aliphatic,